So I think it's really cool that we're all looking at environmental issues that address the health of the land. We're looking at what inhibits or enhances growth for a lot of us, except for some geology. So today I'm switching it up here, and I'm going to pose the question, are babies born with lower birth weights in areas of higher outdoor pollution? Okay, so although more than 90% of babies are born at what's considered normal birth weight, which is around 2,500 to 4,500 grams, about 6% are born what's considered low birth weight, and that's less than 2,500 grams, or about 5.5 pounds. And why do we care that babies are born too small? Well, the risks associated are death, physical and cognitive disabilities, and chronic health problems later in life. And a majority of costs associated with newborn care are because of low birth weight and prematurity and associated birth outcomes. So in Canada, over the years, the rate has been slowly increasing in recent years, and it changes over the provinces. About 3.7% in Northwest Territories to 7.6% in Nunavut, but the really higher than national average rates are in Newfoundland, Ontario, Alberta, Yukon, and Northwest Territories. And this map shows a little bit more detail of health regions where we have significantly higher areas of low birth weight compared to the national average. So you can see that orange blob in Alberta. So that brings us to looking at our study area of Edmonton and the greater Edmonton area. And I have a bunch of maps together so you can see where people live and the births are occurring simultaneously. So the blue map shows the total population. The green map shows all births from 2006 to 2012. And the purple one shows the low birth weights. And the darker the colors indicate, the higher the numbers. So previous research on low birth weight has looked at environmental exposures, and I'll talk about more of that in the next slide. But first, here's an overview of my research questions. The null hypothesis states that there is no difference in birth weight in areas where mothers have more potential for exposure. And the alternative hypothesis, what I'm interested in here, is babies have lower birth weight in areas where mothers have more potential for exposure. And these exposures that have been associated with low birth weight include personal exposures. So things like contaminated drinking water and tobacco smoke. I don't have spatial data on that, so I can't map it out. But also air emissions from industrial and traffic. So the orange dots here show chemicals that are released by industrial facilities. The blue dots are gas stations. Then we also have land-based exposures and things like transmission lines and roads, so our red lines and our gray lines. And then you can have things like pesticide potential from cropland, the green areas, and then we have oil, gas well pads here as well. Ideally, having personal monitoring data for mother's exposure would be ideal, but you don't, especially when you're looking at births from 2006 to 2012. So we use these spatial proxies as done in previous research. And so to approximate these exposures, we assign the postal code of where the mothers lived as recorded on the birth registry, the births that occurred, with the environmental variables. And these are calculated using ArcGIS software. And we're spreading the chemicals released to the air from the industrial facilities across the surface. Also, we're looking at linear density of kilometers per square kilometer of roads across the study area. And we look at the distance to human impacts, such as well sites. And so all birth weights are included in the simulated data table. I can't show you real data because of crazy freedom of information protection and privacy for health data. But to minimize some of the confounding factors that we deal with in health data, we filtered for firstborn, babies born at term, so 37 to 40 weeks, single births, so no twins, and live births. And I have some really crazy scatter plots I'm not going to show you because it'll give you a headache, but just wanted to show you my dependent variable birth weight is fairly normally distributed. There's a lot of outliers that I need to deal with. And the histogram for birth weight shows it's somewhat normally distributed as well, but not so much for the independent variables. I have a lot of skewed data, like some of you, especially really high numbers of zeros in the air pollution that we see across the top and the distance to the human impact facilities. So, my initial data explorations indicate a lot more work is needed. As I mentioned, I have these crazy clouds of square scatter plots that I need to deal with. But there's many confounding factors that have not yet been accounted for, and I'm still negotiating getting maternal variables and socioeconomic status indices that should help tease this apart. And so that's it. So my research isn't too much different than yours. I'm just looking at human habitat.